Hello, in this lecture, we're going to continue on with relational algebra. So we talked about rename operator a little bit in the previous lecture. So I will talk about how you could rename not only the name of the table, but also the names of attributes. Okay, so there are three ways of doing this, right? So this is called row, this symbol. So that's what you use to rename something. So here we have S. So that's going to be the new name of the relation. So the original relation is R, the one we have in parentheses here. And then we have renamed it to be called S. And then in parentheses, we have a list of attributes. Okay, so we have renamed those to be called now B1, B2, all the way to Bn. Okay, the second one is taking the relation R and then it's renaming just the name of the relation to be called S. So notice how there is no list of attributes here. So we have only renamed the name of relation. The third option is renaming the list of attributes. So we took R and the name of the table is the same, but we have renamed the attributes. Okay, B1 through Bn. So these are your three options. So here is an example of a table called bars. Okay, we have name and address. Okay, and Joe's and the address is on Maple Street. Sue's is located in on River Road. Okay, so here I have the rename operator row, and then I took the original table called bars, and I have renamed to be called Vegas bars. So now the name of the table is called Vegas bars, and notice how the names of the attributes are exactly the same as the original. The second one I have renamed bars. Okay, so the name of the table is the same, so it's still bars, but we have renamed the attributes to be called bar name and address using ABBR. So now names of attributes have been updated to be called bar name and ABBR. The last option is to rename the name of the relation as well as the attribute names. So the name of the relation is called the Vegas bars, and then names of attributes have always also been updated as well. So these are your three options for renaming a relation. Okay, so you can, we talked about taking a Cartesian product between two of the same tables, right? Okay, so we have bars and bars. This is the original bars. We are doing a cross-referencing. We are taking every single combination between bars and bars. Okay, so we have renamed the first one to be called bar 1 and then bar 2 for the second one. So that way we are able to distinguish which name and which address it's coming from. So the first one will be bar 1 dot name, bar 1 dot address. Okay, so for each one we are taking every single combination with another reference of bars. So now we have combined that with bars 2 dot name and then bars 2 dot address. So it's resulting in 4 rows of data. Okay, so instead of specifying a condition where we set something equal to each other, we can use natural join. So natural join is kind of like Cartesian product, but it returns only the ones where whatever common attribute the two tables have, it will only return the ones where the values are equal to each other. So let's see what we mean by that. So we have cells, which has bar, beer, and price, and we have bars, which has name and address. Okay, so we are taking a natural join between cells. This is a natural join symbol, and then bars. So let's take a look at the attributes. Okay, which attributes do we have in common? Do we have bar in here? No. Beer? No. Price? Also no. So this actually would not really work because in order for you to do a natural join, you do have to have a common attribute. So, but in semantics, cells bar should actually be the name of the bar. So bars.name should equal to cells.bar. Okay? So you do have to specify that. Okay, so we have same thing, cells and bars. Okay, so here we could rename this to be bar, or we could just have this as name. So we have Joe's and Joe's here. So this first line row of data will be matched up with this one. So it's going to return Joe's, but 250, and then Maple Street. Okay, because we have Joe's in common. So the second row will have Joe's, Miller, 275, and then Joe's. It has Maple Street. So we have Maple Street being the second row. Okay, Sue's, we can find that here. So it's going to return Sue's, Bud, 250 with River Road, Sue's, Coors, 3, and then River Road as third row. Okay, so we also have bars, S's. So do we see S's here from bars table? We do not. So that means that this row, we're not able to return it. Okay, so this is going to be the resulting table from natural joining the two tables. Here's another example. One has employee, which we have their name, and then their social security number. We have dependents. Okay, social security number 2, and then D name is the name of the dependent of the employee. Okay, so we're taking a natural join between employee and dependent. Okay, so notice how we have name and social security number 2, and then D name. So these two tables don't really have any attribute in common, right? But the social security number, this actually in semantics should be the social security number of the employee. Okay, so we're gonna set them equal to each other. We're doing a Cartesian product between employee and dependents, and we are renaming this SSN 2. Okay, so we want the social security number to be the same as dependents, that's social security number 2. Okay, so if they have these in common, we want to display their name, SSN, and the name of the dependent. So let's take a look at the first row, John, and then we have the nines. Okay, we can see that this dependent, the first row has the nines. So it's going to return John, the social security number with Emily. Okay. And the next row has Tony with sevens. And we can see that the sevens can be found here. So it's going to return Tony, the 7, and Joe. So it's returning the ones where we have common values for a particular attribute. Here, we're specifying that we want the SSN to equal to SSN2. Okay. Here's another example. We have R, which has A and B as their attributes. S has B and C. So we can see that we have B attribute in common, right? So let's see. So the first one, we have X, and then B is equal to Y. Let's see if we can find Y in here. So we see that Y is not a value for B, so this will not be returned. Okay, the next row, we have X and then Z for the value B. Let's see if we can find Z here. We can. So we have the first row and third row. So it's going to return X, Z, and U, X, Z, and V. So those are shown right here as the first two rows. Okay, third row from R, we have Y and Z. So again, we can find Z here and here, right? So it's going to return Y, Z, and U, Y, Z, and V. So the next one, we have Z and V. Okay, do we have V? Yes, we have V here. So it's going to return Z, V, and W as the last row. Okay, so this is a natural join symbol. It's going to return between the two tables that you're joining. It's going to return the ones where the common attribute, which is B in this case, have the same value. Okay, you can also specify which one you want it to be. Let's take a look at this first example. So we are doing a natural join between instructor, teaches, and course. Okay, it's gonna return the ones where these whatever attribute they have in common. And we have a predicate here where we want it to be from the computer science department, and we want to display the name and the title. Okay, so you could have done, instructor, natural join, teaches, natural join, course, or you can do, joining the two tables first, and then whatever we get from as a result, we can join that with course. So these are all equivalent. It's just a matter of, joining two tables first and then joining with the other, or you just joining all three at the same time, but these are equivalent. Okay, having instructor and then teaches later versus teaches and then instructor, these two are equivalent. They do the same thing. Okay, this is a data join. Okay, we have this data. Okay, so where you can specify some condition or predicate. In this case, we have added this condition where department name is equal to computer science, so that will be on this data portion. Okay, so you can have the condition here after select, or you could have it here right after the natural join symbol. Okay, we also have theta join, so we're taking a natural join between R1 and R2, okay, and we want to apply this condition to the result. Okay, and this would be some kind of a Boolean expression, so it could be, less than or equal to, greater than equal to, not equal to, or equal to any of those that gives you either true or false as the value. Okay, so here we have an example. We have cells and bars. We're doing a natural join between cells and bars. But here we want to set cells.bar is equal to bars.name. Okay, so we have that condition in here. So this will be either true or false, right? Okay, here is another example. We are joining bars and cells and bars. We're setting cells.bar equal to bars.name. And this will be what you're getting as a result. You also have equijoin, so the only difference between this one and the theta join is with equijoin, the predicate you have here can only have equal to sign. Instead, you cannot have, less than, you cannot have greater than. Okay, you can only have something that has this equal sign. Okay, you also have semi-join. This is sometimes used. So this is a symbol that you use. It looks kind of like a natural join, but then you actually don't have a closing one here. It's kind of open, it's left open, and the direction does matter. So we have a semi-join. We're joining employee and department, right? So let's take a look at which they have in common. They have department name in common, right? Okay, so let's take a look at the first one. We have Harry, employee ID is 3415, department name is finance. Okay, let's go to this table and see if we can find finance here. Okay, are we able to find finance? No, so we are not able to use it, and we're going to go to the next one. Okay, we are looking at Sally, 2241, and then do we have sales? Yes. Okay, we are able to find sales here. Okay, so we're going to return that row of data, but notice how we're not really returning this manager, right? Okay, so that's what the semi-join is that it's only going to display the attributes from the left-hand table. Okay, next one is George. We have 3401, and finance is the name of the department. Finance, we're not able to find here, so we skip that one. The last one is Harriet with 2202. We have sales being the department name. We are able to find that here. So that row of data is returned, but again, the manager is not there. Okay, let's try switching these. Now we have department name, semi-join employee. So we're going to go here, start from here. We have sales and Harriet. We're able to find sales in two places. So we will return this row of data, but we actually don't care about Sally or employee ID, Harriet 2202. These are not returned. Only the attributes from the left-hand table, which is department, are returned, which will only see department name and manager. The last row of data, we have production being department name and Charles. Production is not found here, so this row of data is not returned. Okay, so let's take a look at these exercises. Okay, so we're using the same relational database. We have employee, works, company, and manages. So find the names of all the managers who manage Calvin Harris, but not Martin Garrix. Okay. Assume that an employee may have more than one manager. Find the names of all the managers who manage Steve Aoki or David Guetta. Assume an employee has more than one manager. Okay, so I noticed that you guys are not really, you probably skipped through the pause that you're supposed to be working on this. So I really highly recommend that you actually work on these. It will really help you. Without you actually trying it, I really doubt you will actually learn how to do these queries. But if you well, hopefully you are working on it. So you can just go ahead and pause this video and like work on it. And once you're done, you can just start playing and you'll get to the answer part. So number one, we're finding names of all the managers who are managing Calvin Harris, but not Martin Garrix. So this was actually from the previous lecture. Whenever you see the keyword but not, this is the symbol that you're using, right? Okay, so the first part of the query is going to be returning the names of all the managers, okay, from the managers table where they're managing Calvin Harris, okay, and then but not, that's the symbol for it. And then the last half of this query will return all the manager names who are managing Martin Garrix. Okay. The second one is or. So this is the symbol for or. Okay, so the first portion is going to be returning all the managers who are managing Steve Aoki, or this is symbol for or. The last half is returning all the managers who are managing David Guetta. Okay, you could also do it this way. This might you might have different preferences. Okay, the second option is you're taking managers and it's returning all the manager names who will either manage Steve Aoki or David Guetta. Number three, find the names of all employees who earn more than every employee of small bank corporation. Assume that all the people work for at least at most one company. Okay? And then number four, find the names of all pairs of employees who are managed by the same manager. Okay, so this number four might be a little bit tricky. Just to give you a hint, you will be doing a Cartesian product between two tables. So again, I can see that some of you are just skipping through. I highly recommend you actually work on these. Okay, so just go ahead and pause it, and once you're done solving it, you can hit play again. So number three, uh, we're finding the names of all the employees who earn more than every employee. So I guess whoever makes the most. So the first portion, we have the names of all the employees who, has a job, who's working. And then we have the symbol minus. And then the last portion, this is going to be all the employees who have, who's making less than at least one other person who works at small bank corporation. So we are taking a Cartesian product of works. And because we are taking a Cartesian product between works and works, we want to distinguish these two tables. So we're going to rename the second one to be called works2. So we're taking a Cartesian product of works and then works2. Okay, so here we are kind of comparing two different employees. Okay, we don't want the names to equal to each other, meaning we don't want to compare, the same person, right? So the e name from works and works2 are going to be different, not equal to. The and symbol, okay, we want the e name from works salary to be less than or equal to works2 that salary. And then here it says earn more than every employee of small bank corporation. So we want works2 to be working at small bank corporation. Okay, so if this person is making less than or equal to some employee, at least one other employee who works at bank corporation, then these people don't qualify, right? So we're taking a list of all of the employees and we're subtracting the ones where they make less than at least one employee of small bank corporation, right? Okay. Number four, we're finding names of all pairs. So we're going to be returning pairs of employees. So it's going to be an employee's name and another name, okay, who are managed by the same manager. Okay, so we are calling this table managers and managers. We're calling it P1 and P2 just for short. You could have named it, M1, M2, whatever you guys want to call it. Okay, so these are two different instances of managing. Okay, we want the names of the employees being managed to be different. Okay, so P1.e name is different than P2.e name. So these are two different individuals we're dealing with. but they're actually being managed by the same manager. So P1.mname is equal to P2.mname. Okay, so they're different people, but they have the same managers. So P1 and P2, and then we're going to be returning their names, P1.ename, comma, P2.ename. Okay? So this will return all pairs of employees. Different, they should be different names, but they have the same managers.